Yes. All right.
Okay.
Get back to my other meeting. Sorry.
That's okay. That's okay. Okay. Laterals. Want help. Just want to understand that first. Anybody?
Can you repeat the question, Swati?
Like your topic is quadrilateral, right?
Yes.
You selected the topic. So what do you want in that?
Ganesh, can you? Mostly quadrilateral is dealt with 8th grade and 9th grade children. When do you want in quadrilateral? Ganesh, can you hear me?
Yes, Arun. Now I can hear you.
Is what do you know? She's asking.
So Ganesh.
You can go ahead.
Yes, Ganesh. Yeah. So Ganesh, what do you want to know or regarding quadrilaterals? What are your questions?
My class 9th, I was trying to go through properties of the quadrilateral. Both
Right.
angles are equal. Diagonals bisect each other perpendicularly.
Right. So you want to know how to explore that with children? Okay. Now I'm going to turn on video at certain points because without that it may not be possible. But let me start with a PPT. Okay. Now I have played with quads quite a bit, and I have consolidated some of my thoughts, and it is interesting, exciting, etc., etc. Also, we do have a pullout. So let me share that link with it, because if you take a look at the pullout, that will probably answer a lot of your questions. But more importantly, if you are talking about class 9, what is very critical is you can do all the explorations, paper folding, etc., making different kinds of models. But at class 9 level, you absolutely need to get into proofs. Okay. And the explorations that you do can be utilized to get into the proofs. In fact, if you can bridge the two, nothing like it. Okay. So this is the link. I'm putting it in the chat. This is the link for the quadrilaterals pullout. Definitely take a look. Okay. And as as always, any question, any doubt, you can always reach me. Okay. Now, let me share my PPT. And yeah, I have been working on it. So, and no animations today. I will just, I'll not even project. I think this should be fine. So, I believe everybody can see it, right?
Yes, sir.
Yeah. So when you start with, and I'm not going to talk only about class 9, I will start from class 6, let's say. See, at the primary level, there are only two quadrilaterals children are exposed to. That's the rectangle and a square. And usually they can isolate a square, but it is very important that we don't mention that a rectangle is not a square. In the sense, or rather, that a square is not a rectangle. Okay, so it's a it's a superset subset relation. All squares are rectangles, but obviously, so squares are special kind of rectangles, and that notion should be there. Okay, now So in class 6, they basically get exposed to this, all these other quadrilaterals, rhombus, parallelogram, trapezium, kite, etc., etc. So first of all, they should be able to just see a shape and recognize, okay, this is a kite, this is a rhombus, this is a trapezium. That is important. One option is you make paper cutouts and you ask them, okay, so now isolate the squares. Okay, then you isolate the rectangles. See, once the squares have been isolated, then what you will get is the rectangles and non-square rectangles. Okay, then you isolate the rhombus and you go like that. Okay, and then what you can do with these paper cutouts is you can fold to see which sides are equal, which angles are equal, and so on and so forth. So now let me give you a little bit of demonstration to illustrate the point. Okay, so let me turn on video for now. Okay, let me see how much light is there. Okay, not as much as I wanted. Okay, let me just quickly switch my. Okay, this may be better. Okay, hang on. Okay, so let's say this is a rhombus. Okay, now when I fold the rhombus, so what you should do is you should label all these vertices as A, B, C, D, or whatever. Now, when you fold this in half, okay, now you can see two sides will match, and which two sides? So these two are equal because they superimpose on each other exactly. Similarly, these two are equal because they superimpose on each other equally, right? So you are getting two pairs of equal adjacent side in the first fold. Then you need to, and you also get that these two angles are equal. Now, there are two ways you can go. Second is you can fold it now this way. Okay. And then you get that these two sides are equal and these two are equal. Okay. And of course, these two angles. So it will be like that, if you have AB, let's say A, B, C, D. Okay. So when you fold it this way, you get AB equal to AD. Okay. And when you fold it this way, you get AB equal to BC. So now when you combine them, you get AB equal to AD equal to BC. And that way, if you stretch it out, you will get that all sides are equal. But remember, it will not come from only one fold, you need two folds. Okay. And, then you can explore other things like, so this is, you have folded it once and you have folded it another time. And you can see that, you have got a right triangle. Okay. And now if you open it, you have four angles here and all the four angles overlapped, right? So then all four angles together is 360 degrees and all of them are equal. So how much is each angle, right? So you are deducing that. And so 360 by 4 is 90. So therefore the diagonals are perpendicular. Okay. And then you can show that they have been bisected because you can see that from the point of intersection. So you need to draw the diagonals, then you fold along one diagonal, fold from the intersection point and check that the two parts are equal. Okay. So that is how you get that diagonals are perpendicular and they bisect each other. But are they equal? Now, once you know that this is half of a diagonal So if you think of this, then you have already shown this is half of the diagonal and this is the other half, half of the other diagonal. All you need to do is you fold it onto this, okay, like this. Okay, I took this flap and folded it here. Okay, and you can see that these two are not equal. So the diagonals need not be equal. Okay, in case of a rhombus. So this is how you can see that it is paper folding, but it is not just paper folding, it is connected to what you are observing and then logically equating things and, you know, what all can you see and etc. etc. So for each fold, you need to jot down, okay, these things are equal, and then through several folds, maybe deduce everything is equal, etc. So similarly, so these are the kind of things that you can explore at class 6 level. Okay, and you can see a kind of sequence given in the second part, you know, first square, then rectangle, because these are the two most familiar shapes, and square is the with the higher symmetry. That's why I start with that. Rhombus, then kite, because whatever folds you do for rhombus kind of extends to kite. It's very similar. Okay, and then you go to isosceles trapezium. In the syllabus, isosceles trapezium is barely there, but I have a bias towards it because the way kite is related to rhombus, isosceles trapezium is related to a rectangle exactly in the same way. Okay, and then of course parallelogram comes at the end. Now, can anybody tell why we are doing parallelogram at the end in this activity with paper folding? Yes, Shiva. Okay. Now think about it. When you are folding, okay, paper folding. In case of a rhombus, you saw how the rhombus was folded into an isosceles triangle, right? If you fold along any of the diagonals, it will give you an isosceles triangle. And basically, there is, if you think, okay, let me give you a clue, symmetry. Okay, symmetry wise, parallelogram stands out from the rest of these 5 quadrilaterals. What is that special thing that parallelogram doesn't have that the remaining 5 have?
Diagonal bisect at 90° for others.
Well, in a rectangle, diagonals don't bisect at right angle. They bisect, but not at right angle. I'm saying symmetry. I'm giving you a hint. Okay, this will be a homework since you couldn't answer me. Okay, and please somebody jot this down. Take a rectangular piece of paper, parallelogram. Okay, a paper cutout of a parallelogram. Okay, and see if you can fold it in a way so that the two parts you get when you fold it overlap with each other exactly. Is this clear?
We have to check. We have to fold it once only to check.
Yes, one
No.
fold. I don't care how you fold it, but then like you saw for rhombus, right? When we folded the two parts, okay, overlapped with each other exactly. Okay. It's not just halving, but the two halved parts should overlap each other exactly. Now, when you can fold a shape like that, what kind of symmetry does it have?
There is no symmetry while folding, right?
There is some symmetry, but which one is? See, there are two kinds of symmetries. One is the line symmetry or reflection symmetry, reflective symmetry. Another is the rotational symmetry. So when you can fold a shape in half, which symmetry is there?
I think rotational symmetry.
Are you sure? Okay. I frankly don't know how to do justice to this without video. So I'm again turning my video on. I know it becomes larger files, but can't help it. Okay. Okay. So see, this is a kite. Okay. This is the kite in the flex side. Okay. Now, if I fold it this way, okay, you can see that things are not overlapping exactly. Right? Now, on the other hand, if I fold it this way along the other diagonal, you can see that it overlaps, the two parts overlap exactly, just like in the case of rhombus. Now then, what do you call this fold like in terms of symmetry?
Line of symmetry.
Exactly. So what kind of symmetry does a kite have?
Line symmetry.
Exactly. Not rotational. If I rotate it, see, it's not the same. Right? When it was here, these two were shorter than these two. Right? Now, if I rotate it, then these two are longer than these two. So they're definitely not the same. In case of rhombus, yes. If I rotate a rhombus, then it remains the same. Okay. But not for a kite. Okay. So a kite has line symmetry, but not rotational symmetry. Now, think of a rhombus, parallelogram. Does parallelogram have any line symmetry? Okay. So if I try to fold it in half, okay, this way, definitely they are not overlapping. Okay, let me try to fold it along a diagonal. Not overlapping. Yes, these two are congruent triangles. Okay. If I draw the diagonal, the two triangles are going to be congruent. No doubt about that. But they're not overlapping. Okay. And I had folded earlier using the midpoint of the sides. Okay. So that is again this line. It definitely halves in the sense like this and these are going to be congruent. But right now, they are not overlapping. So And you can try it this way also. Okay, still not exactly overlapping. Okay. So does parallelogram have line symmetry?
No.
Exactly. And that is why, okay, we are done with video for now. So that is why we are here. I'm suggesting that we do the parallelogram at the end, because when you want to try it with parallelogram, you need two congruent parallelograms and you need to put them side by side and check, okay, so this side is equal to, so you, if I call them P1 and P2, you match a side of P1 with a side of P2. Then you match that side of P2 with the opposite side of, P1. Okay. I'm not sure if I explained it correctly. So let's say you have a parallelogram ABCD. Okay. And you have another parallelogram congruent to the first one, which is, let's say, PQRS. Now, AB equal to PQ. So you put AB and PQ together, you show that they are overlapping exactly, so they are equal. Now you put CD and PQ together, and you show that, yes, CD is also equal to PQ. So first round, you get AB equal to PQ. Next, you get PQ equal to CD. So therefore, AB equal to PQ equal to CD. In the other words, AB equal to CD. That means opposite sides are equal. This pair of opposite sides are equal. Similarly, you can show AD equal to BC. Okay, because they will both be equal to QR. Okay, so you see, it is not just an activity, but this way it is linked to how you are doing the logical deduction and step by step. Okay, so that is this is something that this should be done at class 6 level. So similarly, when you overlap angles and see if they're exactly equal. Okay, so you can see, find out for sides. Are the sides equal? Adjacent sides, which sides are equal? All, three of them, two of them, opposite sides, adjacent sides, how many pairs of equal sides? All these things can be done. Are the sides parallel? Okay, that also can be checked, not very, very well, but can be checked to an extent. Okay, video for demo. Okay, so if you fold it like this, I'm doing it with a rhombus. If you fold it like this, okay, so that from where you are folding, okay, you see this is a straight angle, 180 degree. And when you are folding it so that these two edges match, then you are kind of halving the straight angle. So you get right angles here. So the fold line is perpendicular to the edge you are folding. Now, if you extend that, you notice that here also the edges are matching. So it's a right angle here and a right angle there. That means that the fold line is perpendicular to both these edges. Now, if two lines are both perpendicular to the same line, then they have to be parallel. Okay, or you can argue it because the internal angles on one side of the transverse adds up to 180 degree. Therefore, these two have to be parallel. Okay, so that way you can show parallel. Okay, there is a problem though. If this parallelogram is too long and thin, if it was instead of this width, like here also, I think it will be possible. Yeah, you can get it completely inside. But if it was like, instead of being so wide, if it was very narrow, then obviously you can't fold and do it. Okay, because the perpendicular will go outside. So you have to be a bit careful on that. Okay, so those things. Angles, again, equal angles, adjacent angles equal, opposite angles equal, those things. And then diagonals, you check if the diagonals are equal, you check if they are perpendicular, you check if any diagonal bisects the other diagonal. Okay, so you can do various kinds of exploration. So I would like you to, explore each of these and see what all you can do, you can come up with. Okay, now the next thing, what you can do. So the first part is basically, you are basically exploring. The second part, you can come up with a tree diagram kind of a thing. And again, I would recommend that you start with square. Okay. So when you talk about types of quads, there are three things you can do. One is the tree diagram. I'll show it in the next slide. The other is you look at it sidewise. Okay. So see, in case of triangles, this is how you can argue. In case of triangles, they are classified sidewise and angle-wise. If all three sides are equal, you call it equilateral. So what will be an see, again, play with the term equilateral, meaning equal sides. So what will be an equilateral quadrilateral? Okay, quadrilateral with all four sides equal. Okay. And then you look at, okay, so what if it is three sides equal and one side different? So you can do many more explorations with that. So you can make quadrilaterals like that with matchsticks. Now, let me tell you straight. If you can try it with like 4 matchsticks, 12 matchsticks, etc. If you take 16 matchsticks, okay, or 16 toothpicks, then all of these will be covered. So that means the total perimeter for each of the quadrilateral is going to be 16. Okay. And how do you distribute that? Okay. If you have Cuisenaire rods, because they have this fixed lengths, 1, 2, 3, 4, like that, that will make life a little easier. But if you don't have them, that's fine too. Once you make them, then you can get to straw models. Okay. And I'll turn on video to show you straw models a little later. Similarly, you can do it with angle wise also. So in an equilateral triangle, this can happen at class 7 and or class 8 when you get into quadrilaterals. Equilateral triangle has all three angles are equal. So you can call it equiangular also. Now, you can ask the question, and in case of triangles, equilateral is equiangular and equiangular is equilateral. But is that the same thing in case of a quadrilateral? So you can ask, okay, what is an equiangular quad? Okay, a quadrilateral whose angles are all equal. I'm asking the question now. I'd like to hear from you. Which quadrilateral has equal, all 4 angles are equal?
Square rectangle.
Which one? Don't give me 2 answers. One.
Both.
No. Come on. Think about what we said about the relation between square and rectangle.
Square.
If you say square, that means there are some rectangles in which all angles are not equal.
Rectangle.
You see, there is this thing that in mathematics, we are very precise. In this case, it will be very concise. Okay. We are very lazy when it comes to using language. We say the minimum, like what is the minimal thing that you can say and that will do the job. So if you say rectangle, that does the job. Square is special kind of rectangle. So, the moment you say rectangle, squares are covered. No need to say it separately. Okay. And these kind of nuances should be brought to children, should be discussed with children. Okay. And upper primary is a good place to start that. Okay. So, but now let me again turn my video on. Now, this is what I'm talking about, straw models. Okay. So each straw is stapled here. Now let's see. You can maybe see that in this case, one end, in each case, one end, okay, one end of the pin is sticking out. So that is why this movement is possible. That's how, this have been made so that, you get this mobility. So if you can cut straws according to size and make this, okay? I'll share the details with you. Now this one is special because here it is inserted, one straw inserted into the other, okay? So that's why it can move. And that's the same in all four sides, okay? Now to make it, you need straws, staplers, and a lot of patience. Okay, that's a very important ingredient for that model. And that second model with the straws inserted is one model which can help you show all types of quadrilaterals. Okay, so when you make these straw models, that really help you explore a lot of things. Okay, because the sides are fixed, you can vary the angles, right? So lot of exploration possibilities are there. But if you want to do the same thing with angles, I mean, what will be the nice way to explore that will appeal to children? Something that can touch and feel. I don't have a very good answer to that yet. Okay. So if you can come up with something, please share. That will be good. Okay. Now the tree structure. Okay. Now you see, can you see how it is different from a regular tree structure? Anybody? See, in a regular tree structure, the branches don't merge, right? But in case of quads, the branches do merge. A square is both a rectangle and a rhombus. It has all the properties of a rectangle and all the properties of a rhombus. Okay, so this is where it is not exactly a tree, but a modified tree, you can say. Mathematically, probably the next slide explains it better, which is a very set type of notation. Okay. Any question, comment, anything? Okay, I guess Sanjeev just joined. Okay, so if you look at this one, you can see a lot of nesting. Okay, and it does look pretty complicated. So don't start with this. Maybe start with this. Okay. But here, basically, you are seeing where you are trying to look at all the intersections. So if you see, if I start here, this one is basically isosceles. Okay, let me go from outside in. The biggest one obviously is quadrilaterals. Then within that, it's convex quadrilaterals. So these two are concave ones, which are outside. Now within them, there is the trapezium, the set of trapeziums. Okay. Then there is kites. And there is isosceles trapezium, which is completely a subset, parallelogram, which is a subset, and kite. And the remaining square, rectangle, rhombus are just intersections. Okay. So I believe this is there in the pullout whose link I have already shared with you. So feel free to sit with it and take a look. Another thing I want to draw your attention to, see, you can see in case of square, all squares are similar shapes, only the size varies. In case of rectangles, the aspect ratios change, okay? In case of rhombus, the angle changes. So you can have very long, thin ones, or you can have like this, which is, almost a square. Okay, so this is like almost a square, whereas this is pretty long. In case of kite, this is important because here the halving diagonal, the one which is a line of symmetry, is shorter than the other one. And unless you expose children to this kind of kite, they may form a wrong impression that, the halving diagonal is always longer. Not so. Okay. So similarly, you have isosceles trapezium and all kinds of them. There are trapeziums, and again, there are three kinds. And then general convex quads. Okay. Again, for parallelograms, like both angle varies and the aspect ratio varies. So have to play around with them.
So the isosceles triangle, can you say what it is?
Isosceles trapezium.
Isosceles trapezium, yeah.
Okay.
How do
Why
you
don't
define
I?
it? Right?
Okay, I don't want to say it. I'm going to share an article. Okay. And I want you to guys to read the article and then discuss. Because the naming and the nuances with isosceles trapezium, I don't think we will be able to do justice to that in 12 minutes. So I'm going to send you various links to several articles, etc. So you'll have tons of reading type homework. Okay, and you can explore as much as possible based on what all I showed you. Okay. Okay. Now, these are the things you can do. This is directly connected to syllabus, very, very core part of syllabus. And there are these two steps. You go from definition and then go into the properties. So for example, when you are talking about definition, let's say, what is the definition of a parallelogram? Not properties, definition.
Like all sides are parallel, like that. Opposite
Not
sides
all sides, two pairs
sides
of,
are parallel.
yeah, two pairs of opposite, two pairs of parallel sides. Adjacent sides cannot be parallel, So how do you draw a quadrilateral whose opposite sides are parallel? So, you can do it on dot sheets. Obviously, before that, children should have a practice of drawing parallel lines on dot sheets. And not just horizontal and vertical lines, but slant lines as well, right? Otherwise, you will get only rectangles, which are parallelograms, but special kind of parallelograms, okay? Now, for parallelogram, that is clear. But when you go to rectangle, rhombus, square, etc., what do you choose as definition is crucial, because from that you want to deduce all the properties. Okay, so that's where I'm going to share an article regarding definitions, and which deals particularly with isosceles trapezium. Okay. Now, so the basic idea is you draw on dot sheet or you do a construction. Now that construction is not possible before class 8 because they don't have all the constructions things yet. Okay. In class 6, they learn some things. In class 7, they learn few bits more. In particular, they know how to draw parallel lines. So utilize those and go, bottoms up. So you construct a parallelogram that way, and then you explore its properties. And in the next part, you do the reverse. See, for example, one of the property, a very useful one is, if the opposite sides of a quadrilateral are equal, both pairs, then it is a parallelogram. So in this case, you pick two sides, okay? You pick two adjacent sides and you pick an in-between angle, okay? And then you complete the parallelogram, okay? You do that with construction, and then you cut it out, or through whatever means you try to check, are the opposite sides parallel? And you can try to do a proof, or you can first explore and then try to prove. Okay, but the proof part should come in, especially at 8-9 level. Okay, and you can do that with all others also. Okay, so two steps. Now these are fun questions, fun things to explore. Okay, first is the partition, concave and convex, and of course you need to look at concave through different lenses. One is the essential idea of concavity, that the envelope and the shape, they are not identical. Like if you use a soft board and you put 4 pins and you put a rubber band through it, okay, if it is and then you release a rubber band around it and it snaps and kind of envelopes all the 4 pins. Now, if it is a convex quadrilateral, then it will be identical. If it is concave, okay, I can annotate and show you.
Yeah. But yeah, makes sense.
Yeah. So I have to go from spotlight and draw. Okay. Okay. So if it is like this, yes, if it is like this, okay, now let me change color. And you snap another rubber band around it, this will be the envelope, the purple one. And they're not equal. They're not the same, right? So that is one notion of concavity. If you think of concave lens in physics, convex lens, concave lens, the same notion comes in, right? So this notion goes beyond polygons. Even with curved shapes with curved lines, the same thing happens. The other one for polygons in particular is that one diagonal, at least one diagonal, will be outside. Okay, so for this diagonal is outside, right? And this one is inside. Okay, the third one is at least one angle is going to be reflex more than 180 degree, and that will be this angle. Now, if you are doing this on a geoboard with a rubber band, or with push pins and rubber band, this comes out very well, because see, this vertex or this peg, okay, this peg and this peg will be inside the rubber band, inside, but this one will be outside. Okay, so that's a kind of association that children can relate to. Unfortunately, there are brilliant virtual geoboards, okay, really nice, with lot of added advantages. But this advantage is missing from a virtual geoboard, at least in the ones that I have seen. Okay, this is where the physical geoboard wins. Okay, and if you use geoboard, it is a good idea to ask children to make things on geoboard and then draw it on dot sheet. Okay, rectangular dot sheet and that kind of geoboard. Okay, so these are things you can do. The answer to the next 2 questions, this largest class and the one that is outside the largest class but intersects with are homework questions if you want. Types of trapeziums. Now, a trapezium can, if a trapezium has a right angle, that's one kind. You can call it a right trapezium. Now, if a trapezium doesn't have a right angle, then it will have 2 obtuse angles and 2 acute angles. Now, how are these obtuse angles placed? Are they adjacent or are they opposite? Okay, so that is what is I'm talking about here. Yeah. Okay, so that's the right trapezium that Sanjeev has drawn. Now, can you draw one where the obtuse angles are opposite to each other?
Oh, you
So
want me?
these two, you'll see pictures of these two in the textbook.
Yes.
Okay, and the second one, so let me just do the text. So this I would like to call right, and this one I will call acute. Okay, now the other one I will call obtuse, and I will tell you why I'll call it obtuse. Okay.
You want me to draw it?
Yeah, why not? Yeah.
All right. Parallelogram sort of.
No, you can do it. Come on. Okay, yeah, that's good. It's not a parallelogram. Okay, so this will call obtuse. Okay, obtuse. Why? You can always think of a parallel trapezium as just like a frustum is a cone truncated. Think of trapezium as a triangle truncated. So if you extend this, one, oh, sorry. If you extend it, it will become, an obtuse triangle. If you extend this, there is possibility, okay, in this is a tricky case, it can become anything, okay? And this case, it will definitely become a right triangle, okay? This one is tricky because it can be a right triangle, it can be an acute triangle, it can be an obtuse triangle, because we have no, this angle can be anything, okay? But still, so this is a loose terminology. It's, I don't think there is any literature on it, but this is one way you can kind of classify the trapeziums. Okay. Now, and the thing is, if you bring in symmetry, or let's say, if you now try to make the non-parallel sides equal, the first one leads to this one leads to a parallelogram. This one leads to isosceles trapezium, and this one leads to
Right.
angle. And it's quite interesting and fun because obtuse and acute are separated by right? It's kind of in the middle. And rectangle is something which is both a parallelogram and an isosceles trapezium. So I find these interlinkages quite fascinating. Okay, so yeah. Sorry if I get too excited. Quadrilateral is something I have been dreaming of for a long time. Okay. So, and of course, similarly, as I said, types of kites, it's a good idea to, explore those kind of things. And symmetries of different types of quads. You can actually, I think you should probably make a, small table like this. Okay. I don't remember the technical term of what it is called, but basically, have it like this so that you have, you have line symmetry, yes, and you have here, you have line symmetry, no, and similarly you can have the rotational yes and no here. Okay, so R yes and R no. So then you can see, which quadrilateral has which kind of symmetry, and you have a sense of this. If you try it with triangles, not all the boxes will get filled. Okay. So the last part which I I wanted to share and I didn't get time to complete it, but I'll just type it out here as we go. So two kinds of explorations that are good. One is, ask this kind of questions. What is a kite and what is and a parallelogram? And come up with your own stuff, right? So the second type will be, what do we need to draw a rectangle? See, to draw a square, you need either a one side or a diagonal. That's all you need. So what all do you need to draw a rectangle? What all do you need to draw a rhombus? And there will be multiple possibilities. So explore that, okay? And then type 3, which probably should have come earlier, is find the similarities and the differences between, let's say, kite and parallelogram. Okay, and this is again a random example. Okay, you can take, let's say, rectangle and rhombus, kite and isosceles trapezium. You can, do these kind of things. Okay, so you can have a whole list of things and you can try them. All of these explorations, these are based on things they learn, but you will, I doubt if you'll find this kind of things in textbooks. Okay, so there's no way they can copy, cheat. They will have to use their logic, understanding, and all of that. Okay, they have to literally argue and prove. Okay, I'm going to leave you with two more questions. And
Are you taking a 2-week break or what?
why I'm rushing?
No, you're giving us so much to do.
I'll tell you that after this. Okay.
All right.
So one way is to see which quadrilateral has which symmetry. Now I'm asking you two questions as challenges. Okay. The first question is, if a quad has line symmetry, prove that it is either a kite or a isosceles trapezium. Okay. The second one is, if a quad, I'll just copy paste because it's very similar. Rotational symmetry, then this is a known result, but I hope you will not cheat by looking up the proof everywhere and somewhere. Okay, this is a known result, the second one. Okay, now a parallelogram has many equivalent properties. Okay, I mean properties which are equivalent to the definition. And class 8 syllabus is kind of dominated by that, the geometry portion. Usually it doesn't include this one. Okay, but this is also true. Okay, so try your hands. Like, one reason why I'm doing all this is because I won't be able to, I won't be there next week. Okay. And the second thing is, this is something I'm really excited about as well. And I do want to write a book. I've done a rough outline. So it's, the excitement part is also there. And I know I can share that with you because you guys also explore as much as, I do, etc. So that is there. So yeah, it's past 12. So enjoy quadrilaterals.
Thank you, Swati.
Okay. Bye. I'll send you a lot of links and yeah.
So Arun will also meet next week, same time, to look at what people have come up with and answer any questions. Yeah.
I will be available over email, etc. So in the way you send me homeworks, etc., and I can communicate over email. If you are ready to open to shifting the day just for next week,
What day is
Saturday is
better for you?
fine,
It should
but
be
not before Friday.
Saturday is okay, right, Arun?
Just for next week.
All right. Do it on Saturday next week.
Okay, then we are not taking a break. We are just taking one day.
Saturday, same time.
Yeah, that is possible.
Sounds good. Thank you.
Okay.
Bye.
Bye.
Thank you. Bye.
Bye.